Here are three short integral examples where we're going to integrate back to inverse trig functions. In the first one, we can see that in the bottom we have the square root of 16 minus x squared. That is the square root of a number minus some expression squared. There's a good clue that this is going to go back to the arc sign, because the arc sign is the only one with the square root of a number minus a variable expression. So I'm going to set each one of these up kind of as if we're using u substitution, because we want to make sure that we understand what's going on, especially with the u's and the a's here. They can be a little bit tricky. So we don't necessarily need u substitution on all of these, but if you just always take a u substitution approach, you should end up getting these things correct the vast majority, if not all, of the time. So for this one, our form is a squared minus u squared under the square root. So that means a must be 4, since 4 squared is 16, and u must be x, since x squared is x squared. So that says that this antiderivative will end up being the arc sign of x over 4 plus c. For the next problem, we don't have a square root in the bottom. That's a good sign that we might be looking at the tangent. So in this case, we'll let u be equal to 3x, since 3x times 3x is 9x squared. We'll note that du is equal to 3dx. And we'll note that a must be 2, since the 4 is a squared. Now, if we apply all of that to our formula, and we notice that the 3dx here works out perfectly, so that's why we don't necessarily need to go through the whole u substitution. You still could, but this is more important just to help us see what's going on, and especially make sure we pick our a correctly. So we're going to end up with 1 over a, which is 2, times the arctangent of u over a, which is 3x over 2, plus c. And that's what our arctangent looks like. Now, I didn't mention on the first example, but if we let u be equal to x, then du is equal to dx, and there wasn't much going on there, but I probably should have noted it as part of walking through the substitution process. For the third example here, this definitely looks like it's going to be something that involves the secant. The order of the subtraction is reverse of the order of subtraction for sign. That is, we get the variable part first, then the number. We also have something out front. Now, depending on how things were simplified, there may not always be something out front. So noticing the order of the subtraction is sometimes very helpful in determining that we might be going back to an arc secant, assuming this doesn't integrate back to something else entirely. So in this case, u is going to be x, since x squared is x squared. That makes du dx. And a is going to be 5, since 5 squared is 25. And that says that we will integrate back to 1/5 times the arc secant of the absolute value of x divided by 5 plus c. And there's our form. Don't forget that the arc secant form here does have an absolute value that shows up in it. Shouldn't be hard to remember, because these are forms that I will not expect you to memorize. I will provide these for you on tests and on the final exam. You just need to make sure that you know how to apply them properly.